Good afternoon, everybody, and I can see lots of people are just joining in at the moment. We just left it for a couple of extra minutes to let a few more people get online for the webinar. Welcome to the next in the series of the DeepCrawl webinars. My name is John Myers of DeepCrawl, and really happy to be here again to take you through another topic that's pretty pertinent within the SEO industry. And today's webinar is aptly titled HTTP2 for SEO. So obviously all you guys are in the right place. It's great to have a fantastic speaker on this subject, and Mr. Tom Anthony, who is the head of R&D at Distilled. It's great to have you, Tom. Thanks for taking the time out to be with us.
Thank you very much for having me. I'm excited.
No problem. Thank you, mate. Bit of background before we get into Tom's presentation. Obviously, Tom has been in the industry for many years and has been with Distilled now for over 7 years. As mentioned before, I mean, there's great stages all over the world talking about this subject. So he's a great authority on this, and the deck looks fantastic. So no pressure on Tom to deliver today, but I think there's some really helpful things throughout the deck as we get into the topic as we go over the next hour. I mean, really, this is the first major revision of HTTP, and effectively the last 20 years, effectively. So it really was time for this to happen, especially when you think about the importance of things like request times in the ever-increasing world of mobile, and that was touched on in our mobile webinars of the previous few months as well, and obviously the positive effect that can have on site speed, which was obviously our last webinar as well. So there's a huge amount of things that I hope that you guys are going to take away from the webinar today. It will be the usual format. Tom's going to present for about 30 to 35 minutes, and then we'll get into some conversation. As you well know, for any attendees of these webinars in the past, we love questions. So please do submit your questions via the chat box within the application as we go. If Tom mentions something that you'd like to hear back or some clarification on, get your question in there, and then I'll pick through the questions after the presentation and make sure that we get everything answered for you as well. We love feedback too. So at the end of this webinar, when you close it down, you will get a feedback form. Please, please, please take the time to fill that in, because we'd like to see how we can make things better, your suggestions on topics, or maybe some things that we can just change up in some ways, or suggestions around speakers as well. As always, this is going to be recorded, and tomorrow morning we will send out a link to everybody that's signed up with a full recap that will go out on the DC blog, plus all of the slides, so do watch out for that in the morning. But thank you for you guys, and the numbers just keep going up, up and up and up for attending us live over the next hour. It's great to hear it from the horse's mouth as such, and hear it as we go. And I can already start to see some questions coming in. So Tom's even actually got to a slide, which is great to see. So we will come to those in a bit. But without further ado, I'd like to take a seat back and listen in like you guys, and hand over to Mr. Tom Anthony of Distilled to talk to us about HTTP2 for SEOs. So over to you, Tom, and I look forward to the presentations. I'm sure everybody else does online. And thanks for taking the time.
Thank you very much. Okay, so press these buttons, all buttons. Okay, so yeah, as John said, we're going to be talking about HTTP2, which is a sort of pretty exciting topic, especially if you like trucks. But before I actually start talking about HTTP2, I wanted to talk about, oh, we have a technology failure. Bear with me 1 second. There we go. I wanted to talk about an issue that affects the internet and most people aren't aware of. That's an underlying issue with the internet, and I wanted to highlight that with a silly story. So in 1996, a gentleman named Trey Harris was responsible for the entire email system of the University of North Carolina. And Trey was having his morning cup of coffee one day, and his phone rang, and so he answered the phone, and it was the head of the statistics department, the chairman of the statistics department. So Trey sat up, because it was very unusual for someone so important in the university to be phoning him directly. And he listened as the professor explains that he wasn't sure if it was because of they were running out of power or what the problem was, but he and nobody in his department could send an email more than 500 miles. And so Trey sort of spat out a bit of coffee when he heard that, and suddenly was in that predicament where you need to answer somebody in such a way as they're a very important person, so you don't want to make them sound like an idiot even though they haven't necessarily understood something. So he sort of said to the professor, let me have a look into that and I'll get back to you, sort of chuckling to himself about the idea that you can't send an email more than 500 miles and not wanting to say that's not really how email works. And over the next few hours, Trey sort of became more and more shocked as he discovered that, sure enough, he couldn't send an email more than 500 miles. And in order to understand what the problem is, you need to understand how emails are sent around the internet. And basically, one server has to open a network connection to another server in order to send it data. And so the time it takes to open that network connection is called the latency. And it's governed by basically the speed of light, which is not something we normally think about as SEOs, but the speed of light determines how quickly you can open up a network connection. And what had happened was that on the server, someone had misconfigured it so that the connection timeout was about 6 milliseconds. And if you look at the speed of light and you do the maths, in 6 milliseconds, if you're looking for how far in a round trip light can go, it works out to be about 500 miles. So what had started off seeming like a silly problem was actually a real problem, and it was tied to this problem of latency, which is something that affects how we load websites. And it plays massively to site speed. So that's where HTTP2 comes in. HTTP2 was originally a Google research project, and we'll talk about that a little bit, designed to offset the issue of latency and the impact it has on web page loading times. So today I'm going to talk quickly about HTTP1, what it is if you don't already understand it, the current sort of standard for best practice for sort of communicating between browsers and servers. Then I want to talk about HTTP2, what it is, what it changes, how it works, what it means for us as SEOs, and then I'll quickly wrap up before we take some questions with a few takeaways for what it means for us. Okay, so before I get started about HTTP1, just to reiterate why it's important, a few months ago, John Mueller at Google confirmed to us that Google are now using usage data from Chrome users to measure site speed. So how fast your site is for actual users is now being recorded by their browsers and sent up to them at Google as a ranking factor for how fast your site is. And with HTTP2, you can hopefully, I'll demonstrate that as we go through the presentation, you can present the whole your website much faster than normal. So it's a big opportunity for us as SEOs to improve our site speed and to actually potentially get a small ranking boost, and it's pretty easy to do. Okay, so let's start off by talking about HTTP 1.1. So hopefully you'll be familiar with this. You'll have seen this in your address bar when you're going to websites. You'll see this HTTP://. And basically HTTP is the language, the protocol that your browser speaks to a web server in order to communicate and deliver and request websites. So HTML pages, but also JavaScript page files, CSS files, images, all of that stuff is sent over this HTTP protocol. And we're not going to get today too deep into the sort of weeds of the technical side of how HTTP works in terms of the sort of innards of it. But very quickly, looking at a request, looks something like this. I want to get an /anchorman. This is the file or folder that I want to fetch. HTTP 1.1 reiterates which protocol I'm speaking. And then I might send my browser might send a few headers. So things like host header. Here I'm going to wrongburgundy.com. This is sent because some servers might be the home of multiple websites. So your browser needs to specify which website it's trying to connect to. And then most SEOs will be familiar with the user agent header, which is going to say which version of Chrome or Firefox you're using, or indicate whether you're a bot like Googlebot. So you're going to send this request, a few headers, and what you're going to get back is a response line that will look something like this. So 200 is the status code, and then you're going to get back some headers. In this instance, we're showing content type, showing that I'm downloading an HTML page, and then you get the body of the response, which is the actual content, be that HTML, CSS, an image, whatever it might be. And it's important to understand that a single HTTP request is for a single file. So one request might be for a web page, an HTML file, it might be for an image file, it might be CSS font file, whatever it might be. But every file that you download is a single request. And so this is where the trucks come in, the famous trucks. I got very carried away, as you'll see as we go through this. with the sort of truck analogy, but we can imagine that an HTTP request is a truck that is going to carry data between our browser and a web server. So we're going to put data into it. It's going to drive over to the website, web server, and it's going to drive back. And if that's true, then it needs to have a road, and that's the TCP connection. So you might be familiar with TCP/IP from something inside your Wi-Fi settings. It's not important. All you need to understand is that for us to be able to communicate with a web server, we need to have a network connection open. That's what TCP provides for us, and we can think of that as being the road in this truck analogy. So this is what a request might look like. We load into the request into our little truck, and it's the GET request that I showed you earlier, and then a response is loaded into that truck when we get it to the server, and it just drives back. Okay, so immediately we've got a problem with this, in that anyone can look down into our trucks and see what they're carrying. And if you're going shopping on an e-commerce website, this could include something like your credit card details, which you obviously don't want people to be able to spy on. If you're connecting to your webmail, your Gmail, you don't want people to be able to read your emails, but they're all going to be getting carried back and forth by these trucks. So this is where HTTPS came in. And so to continue the amazing truck analogy, that you can think of HTTPS as essentially being this tunnel that our trucks are going to drive through, and that's going to prevent people looking into them. That's the encrypted layer of HTTPS. But what's really important to understand is when we have this tunnel, we're changing something about the road. We're not changing anything about the trucks. The trucks are still exactly the same trucks as they were before. They're still carrying exactly the same data back and forth. And so the requests and responses look the same as they did before. Status codes look exactly as they did before. So nothing about the actual HTTP mechanism actually changes. We're just putting this tunnel over the top of the road to stop people sort of peeking. So at this point, everything sounds great. We've got HTTP trucks, we've got secure HTTPS, and so why do we need to change anything? What's the problems with HTTP 1? There's 3 problems I'm going to take you through quickly. The first is that our trucks can only travel at the speed of light. And so HTTP requests themselves are very small. Most HTTP responses happen to be quite small. A lot of web pages, the HTML is quite light. But what's important to understand is that doesn't matter because our truck can only travel at a certain speed. So it doesn't matter if it's carrying very little data. It still takes a certain amount of time to get from A to B. And so the longer our network connections, the longer our roads are, think about the 500-mile email story I told you at the start, the longer it's going to take trucks to drive to the server and come back. The latency, the network latency, is going to be increased whenever we have these longer network connections. The second problem is that we talk about web pages, but a web page isn't a single thing. It's actually loads of different things all piled on top of each other. So, for example, you've normally got a whole bunch of images. You've got CSS files, which tell you how to lay out the page. You've got JavaScript files. So the browser has to collect the HTML, then it has to collect the image files, and then the CSS and the JavaScript files. And the CSS and the JavaScript files then in turn might reference other files that the browser has to go in and collect. And typically, what's been happening over time is that the web has become richer and richer, but that means there's been a huge increase in the number of files that are involved in making up any particular web page. And typically nowadays, it's sort of 50 to 100 separate requests to serve a single web page, sometimes even more. And so we've got a lot of these trucks driving back and forth, a lot of latency building up. And then the third problem is that we live in a mobile world and people are often on the move and using 3G or 4G connections, and they increase latency even further. You can basically think of them as being bumpy roads where our trucks can't travel as fast as we might like. So all of this adds up to a sort of significant problem in terms of this problem with latency. We keep coming back to it. Every time we send a single truck, how fast it can get to the server and back is going to be more waiting time for our users trying to load our website. So let's have a look and break this down for what it might look like for a single web page. So the browser on the left says, I want to get this HTML file. And so it sends off a request in our HTTP truck, and the truck drives over to the server. Let's imagine that takes about 50 milliseconds. And then the server might take sort of another 50 milliseconds, for example, to do database requests or whatever it is, to sort of in WordPress doing database lookups to build the HTML for the web page. And then it puts that into the truck. The truck drives back to our browser. That takes another 50 milliseconds. But at that point, the browser, as we talked about, says, oh, look, this HTML references these other files. So now I need you to go and get these other files. And this is where we come up against like a major problem of HTTP 1, which is that a single connection can only handle a single request. We can only have one truck on a road at any time. And so if we want to collect multiple files, we're immediately going to have a problem. So what happens is that browsers typically open multiple network connections to the same server so that they can send multiple trucks at the same time. But this in itself introduces another problem. And so we're going to introduce into our truck analogy. I did tell you, John, I got a little bit sort of excited, carried away with the whole truck analogy. But so we're going to introduce steamrollers. Before we can send a truck to a server with a request, we need to create a road. We need to lay a road down it. So this steamroller has to lay down the tarmac, and then it has to come back all the other way, painting the stripes onto our road so our truck doesn't crash. And so this is another sort of full round trip. And this is also our steamroller can only travel at the speed of light as well. So this is another instance of latency sort of impacting our page performance. And so this is basically opening another TCP connection, and it takes a fair amount of time to do that. Typically, browsers will open about 6, sometimes more, 6 to 8 connections to a specific server. So we can have 6 roads going to a specific server. There's diminishing returns in trying to open any more. We're not going to drown in the network details too much. Okay, so what this means is that we're going to have trucks waiting. We're going to have requests waiting, because if we're thinking about the example we looked at before, and we're talking 50 or 100 requests for a single page, we can only send 6 at a time to a server. We're going to have a long queue of trucks waiting for a free road so that they can send their request. And this is what it looks like inside a waterfall diagram. So this diagram is from webpagetest.org, which is a great website where you can test the site speed of other websites and break down what's happening where. But you can also see waterfall diagrams if you look inside the Chrome developer tools, for example. And so what we can see here on line 1 is the request for the HTML page. In this instance, we've got an HTML page that is referencing 25 images, and it's got a CSS file. And so this orange and purple part that we see initially, that's our steamroller. That's opening a new network connection. And then at about 0.4 seconds, we start downloading the HTML page. And that takes a couple of 100 milliseconds. And we can see that in parallel on line 3, we've got another steamroller. That is the browser anticipating that we're going to need multiple connections. So it's opening another one in advance. So at about 0.6 seconds, we've collected our HTML page. We've got 2 roads open now. And so we can send 2 more requests, one for the CSS file, and we collect the first image. We can only have 2 requests going in tandem because we only have 2 roads. When those 2 requests finish at about 0.8 seconds, we send 2 more, so on and so forth. But you can see on about line 8 that the browser realizes, okay, we've got a lot of images to collect here. I'm going to need more roads, and it opens up more connections. It sends more steamrollers to open more roads. And so those are all open, and now we've got 6 roads total. So we see basically that we start to send requests for images in blocks of 6. And when one request finishes, another request can start. And over time, we load all the images, and about 2 seconds later, we've loaded all of the images and we can display our web page. And so at this point, hopefully I've sort of made clear the impact of latency, but if I haven't done it at this point, then this graph is from some research really indicates the sort of importance of getting this right. So we can see that along the bottom, as we decrease the latency, as we shorten the road or between the browser and the web server so that our trucks, the round trip time is reduced, it has a huge impact on the actual load time of a web page. Here, saving like 2.5 seconds off the load time of a web page as we decrease that from 200 milliseconds to 20 milliseconds. This is not true of bandwidth. So a lot of people, when they're talking about their broadband speed, they talk about the bandwidth. Your bandwidth means that your trucks can carry more. But because the majority of HTTP requests and the majority of responses also are fairly small, having bigger trucks that can carry more data doesn't really help us improving the load times of web pages. The latency is much more of an impact. And so over time, we've tried various different ways to sort of hack our way around this problem. So anyone who's been around for some time or is sort of a developer will be familiar with sprite sets, sprite images, which look like this, where you basically have got a single image where you've glued a whole bunch of other images together into one image. Then when you're displaying these on a web page, you can use CSS to hide or show certain parts of that image, so that the user's only seeing the relevant part, whether that might be the Google logo or the checkout button, whatever it might be. The reason that people do this is because by combining all of these images into one image, you can put them into a single truck and send them all back together. And so you reduce the necessity for there to be however many, 20 and some trucks going back and forth, fetching all of these files individually, because they'll all fit in one truck, but you just can't put more than one truck on your road at a time. So this is a sort of hack that people did to try to reduce the impact of latency. Another thing that people do to reduce the impact of latency is using CDNs, the content delivery networks. You might know Cloudflare, there's Fastly, Akamai, there's a variety of CDN companies out there all doing very similar things. In that basically what they do is they have servers all around the world, and they basically cache local copies of all the parts of your website that don't change, your static assets, so things like your image files, your JavaScript files, your CSS files. And so you can imagine that if I'm in London and I want to connect to a web server for a website that's hosted in California, that's about a 100 millisecond round trip time. So it takes 100 milliseconds for my truck to drive from London over to California and back. But now imagine that I've got 100 requests, as we talked about. That's immediately 10 seconds of load time of just waiting for trucks to drive back and forth, waiting for network connections, and like this latency problem once again. So what CDNs do is they cache these files, as I explained. And so if I'm trying to connect to this website and it's hosted in San Diego in California, what can actually happen is rather than drive all the way to California and back, I'll collect it from the CDN server that's just around the corner, and that might be 5 or 10 milliseconds. And so immediately we've saved sort of 9 seconds of load time just by having made the road shorter by caching the static files closer to where the user is. So CDNs are a really powerful mechanism, which is why most big websites are using them. But the core problem remains this issue of latency. Our trucks can only go so fast. So this is where HTTP2 comes to the rescue. HTTP2 was originally, it's an internet standard now, but it was originally a Google research project, which is really fascinating. We might talk about this in the Q&A section afterwards, because it highlights the importance to Google of trying to fix this latency problem. They knew how big of a problem it is for the web. So they called the project Speedy, SPDY, and that was in browsers before it later on became a web standard in HTTP2. And HTTP2, one of the main things it introduces is this concept called multiplexing. And multiplexing sounds complicated until you think about it in the terms of trucks. And all it means is that now we can put multiple trucks on a single road. So rather than having to build multiple roads and rather than our trucks having to wait for a free road, our trucks can all just share the same road. So let's have a little look at how that impacts the load time of a site. So I showed you this waterfall diagram earlier on, and it's exactly the same one as I showed you earlier. This is HTTP1, and you can see that we've got this sort of staggered effect as we load the images in blocks of 6. we can see it takes about 0.6 seconds to load the actual HTML. And so with HTTP2, we also see that it takes about 2 seconds to load the whole site. With HTTP2, what happens is we still have to build our initial road. We need one road at least. So our steamroller goes out, we download the initial HTML. That takes about 0.6 seconds. At this point, we haven't saved anything because we've just collected the HTML. But after that, things start to get interesting because now the browser sees the HTML, it says, okay, I need a CSS file, I need these 25 image files. And what happens is that now we don't have to queue up waiting for trucks to have a free road. We can send all of our trucks on the same road. They all go off, we send a whole bunch of trucks, they all go and collect their image files and come back. And we can see the whole website now loads in about 1.1 seconds. This is exactly the same website. We've changed nothing about the HTML. We haven't changed the images in any way, but previously it was taking 2 seconds to load, and now it's taking 1.1 seconds. So that's a pretty significant improvement just for rolling out HTTP2. Important to understand is that as with the move from HTTP to HTTPS, where we added the tunnel earlier, moving to HTTP2, the trucks remain exactly the same. You can just think of HTTP2 as being a sort of new sort of traffic management system, if you will. And so the trucks, the content of those trucks is basically identical to how it was before. Our requests still look like this: a GET request for Anchorman. We still send headers, the host header and the user agent header in this example. The responses are still in the same format. We have header and body, and the status codes are all exactly the same. So we still have 200, 301 redirects, 404 not found, etc. None of that changes. What you already know about HTTP is going to stay true. So that's sort of nice rather than having to learn a whole bunch of new stuff. One of the really interesting and sort of well talked about facets of HTTP2 is this concept called server push. And server push basically is very clever in that with server push, rather than waiting for when a request arrives at a web server, that web server knows that if you're collecting this HTML page, if you're viewing this web page, I already know that you're going to need this CSS file, and I know you're going to need these image files. So rather than wait for the browser to receive the truck and then send another truck requesting those things, what the service does is simply say, okay, look, you've asked me for this HTML file, but rather than just send you the HTML, I'm going to send you the HTML in one truck, but I'm also going to send another truck with this CSS, and I'm going to send you another truck with this image file, just to save you having to request them, because that saves us a whole round trip. It saves us having to wait for a truck to drive all the way back to the server, to the browser, then all the way back again to the server. Server push is obviously a very powerful mechanism, and it can really speed things up, but it's also not normally being implemented very well. You have to be careful not to sort of over push things, so sending the same CSS file over and over to the same browser, even though they've already got it. Typically at the moment, we're seeing people not implement it very well, so just be very wary if you're talking about implementing server push. Important to understand about HTTP2 is that it requires HTTPS. I've not been showing the tunnel throughout the presentation because it'd be a pretty boring presentation if we just looked at the tunnel the whole time, but you can imagine it was always there. And if you want to use HTTP2, you have to have an HTTPS website. HTTP2, in all the major browsers at least, will only operate over an HTTPS connection. So if you haven't already moved to HTTPS, this is a very good reason you should do. You should have already done that, especially seeing as yesterday, Google released Chrome 68. Chrome 68 is the version that will start to show not secure warnings for any websites that are still being delivered over HTTP. So rather than it being not secure warnings when there's a problem with an HTTPS website, the certificate is broken, they're now showing this for all HTTP sites. So that's going to be pretty significant for sort of impact on users in terms of their confidence of using your website. So yeah, if for HTTP2, you need HTTPS. So this all sounds great. Hopefully you're sort of chomping at the bit to get HTTP2. So how do you get it? So the really great news is that because this is a traffic management system, this is a change to our roads. We're not changing the content of our trucks. We're not changing the content of the HTML on the pages in any way. that all stays the same. So your developers don't need to do anything. Your software, if you're on WordPress, you don't need to worry. Don't need to change any of that stuff. This is just a problem for the sort of IT guys, the server level team. So speak to your team about potentially what can we do in terms of upgrading our server to support HTTP2, because then everything else you get for free. If that's not viable and you haven't already got a CDN, then CDNs like Cloudflare, Fastly are a really easy way for you to deploy HTTP2, because a lot of them will provide that to users now. And because CDNs cache your static assets, so they've got local copies of your image files, etc., that means that even if your server still only speaks HTTP1, it doesn't matter, because your CDN is able to serve the respond to requests for your image files, your JavaScript files for you. It doesn't need to speak to your server, so the CDN can just speak HTTP2 to users and immediately get most of the benefits of HTTP2 just through deploying a CDN. Okay, so we're SEOs. We care about Google and what Google thinks. So does Google notice if we have HTTP2? The first thing to understand is we know that Googlebot does not crawl using HTTP2. And so if you're looking in your search console, you're not going to see any changes there if you deploy HTTP2. The crawler essentially doesn't need it. I'll be surprised if they actually started supporting it, to be honest. But important for us as SEOs is to understand that that's not necessarily how Google are evaluating site speed. So this is a tweet from Gary Illis from Google from last year, where he talked about that's not the web rendering job service. The WRS there is web rendering service, and that's basically talking about Googlebot. And so that's not Googlebot's job, is what he's saying. Googlebot isn't the sole way that we measure the speed of sites. And as I mentioned at the start of the presentation, we know now that they have confirmed that they're using what they call Chrome User Experience Report data. You can see this inside their Page Speed Insights tool for like the top 1 million sites at least. And so this is usage data from Chrome users where their browser has measured how quickly does a page load, and then reports that information to Google. What's important is that Chrome does support HTTP2. And so Chrome users, if you deploy HTTP2, will get a faster experience on the website, and that will be recorded to Google, and they confirm that this is playing into rankings. So this is actually going to impact your SEO performance by speeding things up for users. Okay, so quickly wrapping up some of the takeaways. This is, as I said, like a really easy performance win. The sort of speed impact that you can expect is very dependent on the makeup of your website, what it looks like, but it's a high ROI activity for you to be working on if you're concerned about site speed. And using CDNs can make deployment really easy. If you can get a sign up on a CDN, and a lot of them are very cheap, then you can deploy HTTP2. As I mentioned, HTTP2 requires HTTPS, so I think we'll see a lot of holdouts migrating who haven't been concerned about HTTPS before now, just because they want the speed benefits of HTTP2. If you're doing a site audit and you want to understand whether a site is using HTTP2, then easy way to do that is basically inside Chrome Developer Tools. You can go in and you can enable this extra column called the protocol column, and it'll show you which protocol is the browser speaking when it's fetching any particular file. H2 here is just shorthand for HTTP2. So use that as a quick way. If you see SPDY, speedy, inside that list, then just understand that you can treat that as HTTP2 essentially. Speedy was the name of Google's project before it turned into HTTP2. It's being retired, so we'll see it go away slowly and be replaced solely by HTTP2. If all of that sounds too difficult, then you can also just grab this Chrome extension. Don't worry about grabbing that URL, the deck's going out. And so, yeah, grab this Chrome extension and it will show you at the top of Chrome, this site is using HTTP2 or isn't, or is using Speedy or whatever it might be using. Really important to understand is that HTTP1 and HTTP2 can coexist together. If you've got an HTTP2 capable server, but the browser that's connecting to it doesn't speak HTTP2, it'll simply fall back to using HTTP1. And so you don't need to be concerned that you're going to break things for old users or anything. Deploying HTTP2 will not have any impact on preventing older browsers or anything from connecting to your website. Super important for us as SEOs is that moving to HTTP2 is not a migration. Not like moving from HTTP to HTTPS is a migration. When you move from HTTP to HTTPS, you're actually changing URLs on your site, because now you've got HTTPS : / rather than HTTP : and so all of that changes, and it changes the way that browsers have to connect to your server. None of that is true for HTTP2. The URLs will still say HTTPS in them. They won't say HTTP2 or anything. And so there's sort of really no negative impact that you can have on your SEO from deploying HTTP2. It'll be great for users, and there's really no downsides to it. And you don't have all the stress of like an HTTPS migration. And I can really get on board with the stress of HTTPS migrations, because I'm getting up at 3 o'clock in the morning tomorrow to do a deployment for one of our clients, getting them over to HTTPS. Very final thing to understand is that whilst, as I mentioned, Googlebot that won't benefit, Google themselves will notice. This will be sort of reported through Chrome usage data and will have an impact on your SEO, as well as making things a lot better for your users and having second order effects on your SEO in terms of users are more likely to stay on your website, less likely to bounce, etc., if it's more performant. Thank you very much. Hopefully all that made sense. I think there was already some questions before we even got started, and so hopefully there's a whole bunch of questions waiting for us now.
Thanks, Tom. Great presentation and really good sum up at the end there, and with some really good tips. You're pleased to know there is lots of questions, which is great. So for about the next 15 minutes, we'll do some, I'll start going through the questions, and you can give some answers back. I think in some respects, you've openly kind of answered some of those in your summing up, but I think it's probably good to kind of dive into them on a person by person level to kind of just make sure that you kind of cover off the specifics in some respects, and we'll see how many we can get through in the next sort of 15 minutes before we wrap this one up. I'm going to go right back to the start, because one of the first ones from Nilesh, which was about migrations, which is obviously what you finished on. He kind of is just wanting some clarification around, we've migrated our website from HTTP to HTTPS last year in September. First, Google indexed most of the HTTPS pages, and somehow again, Google's indexing some of the HTTPs and throwing soft 404 errors for the HTTPS version of the pages. So I know that you kind of touched on that, but you know, he said he's gone through and implemented all of the HTTPS migration techie things, but is there any quick answer to what he's seeing there with Google kind of throwing up the soft 404s for the HTTPS because it's gone back to the HTTP?
Yes, so I don't know if there's an easy answer, but there's several answers actually. One, because I've been party to many HTTPS migrations and seen all sorts of things happen. So important to understand is that servers can speak HTTP and HTTPS at the same time. So the first thing to double check is that the HTTP version is actually sort of 301ing over to the HTTPS equivalent pages, rather than servers or browsers being able to connect on both. So in some situations, you're able to connect to the product page on HTTP or HTTPS. You've got to make sure you're 301ing those over. Make sure you've got them both registered, HTTP and HTTPS, inside your search console and join them there. And then also set up a third-party monitoring platform, something like Status Cake or Pingdom, which is capable of monitoring pages on your site at sort of intervals. So it could be every few minutes, or it could be a few times a day. And that can actually be useful. Many people use that to check their website is up, but you can also use that to check that, is it having any sort of issue, periodic issue, sort of responding to HTTPS requests. And sometimes we have seen those sorts of issues, and having a tool like Status Cake can help you pin down, okay, for this period of time, the website was struggling to serve HTTPS responses, and that might be confusing Google because they don't trust that your HTTPS site is working necessarily. Once you've got all of that sort of solved, then there's no reason you couldn't deploy HTTP2. There's no reason you couldn't deploy HTTP2 even in the midst of all of that, just because it's a sort of separate axis, if you will. So if someone's already in the midst of doing an HTTPS migration, there's no reason the HTTPS users can't benefit immediately from turning on HTTP2.
Okay, so there you have it. So I'm getting a load of questions now around things like developers and stuff like that. But I mean, one question which just came in from Melody is, are there any downsides in using HTTP2? Any specific considerations or reasons not to do it? Do you see from your experience of doing these types of migrations, is there a downside, or it's just get on with it and get it done, man?
So as I said at the end, like this is very dissimilar to the HTTPS situation, where there were a lot of people saying, oh, you've got to get on HTTPS, Google prefer it, it'll help with rankings, it's more secure. And then other people saying, yeah, but it slows down our website and we've got to register certificates and we've got to do this, that, and the other. With HTTP2, there are very, very few reasons. I can't even think of a reason why you shouldn't be doing it, because everything falls back to HTTP1 if it can't speak HTTP2. I haven't come across a scenario yet where you're really going to be slower speaking HTTP2 rather than HTTP1. So you either speed up the website or not. Considerations might be around things like, so I showed the image sprite sets where people have created sprite sets, and some people have been saying, oh, with HTTP2, then you don't need sprite sets, but there can still be advantages to them. So my advice would more be, if you do deploy HTTP2, just be wary of what advice you're following on top of that. So if someone says, oh, you can do away with your sprite sets, if you've already got them, there's probably not a reason to do the extra work to get rid of them. Just keep them. That sort of thing. But other than that, there's really very little downside, to be honest.
That's good to hear. I mean, I tend to agree. And I mean, just throwing it out, there's a couple of questions around that. John Gutierrez has asked the question, and there was a gentleman earlier on as well. How much resource does it take to make this upgrade from HTTP to HTTP2? From a dev perspective, is it cumbersome, or is it just something that's actually really easy? I mean, you obviously explained the headers and the body tags and everything like that, but is it just an easy thing to get done?
Yeah, and this actually plays to the previous question as well, actually, a little bit. If you wanted to use some of the advanced HTTP2 features, such as the server push that I talked about, where you can sort of send responses before there's even been a request, those are the sorts of things where there is potentially a risk, because server push, as I mentioned, a lot of people aren't deploying it very well. So what happens is that a user arrives on one page and you push the CSS file because you know they're going to need the CSS file. And then they navigate to another page and the server says, okay, they've asked for this other page. Oh, they need the CSS file, and pushes the CSS file again and starts using up network resources when it doesn't need to, because the user's already got that CSS file. Their browser's cached it and it doesn't need it again, even if they're looking around the website. So that is the thing to be wary of if you're deploying to. But it also plays to the dev side of things for the later question, because if you want to use the server push or some of the other the sort of advanced HTTP2 stuff, some of the stuff I didn't touch on, like resource prioritization, where you can say this stuff is more important than this stuff and prioritize these trucks. Those sorts of advanced features might need some of your developers' time, because your developers will need to say, okay, this HTML page needs to push these CSS files or whatever it is. But if you just want the multiplexing, that allowing multiple trucks to go on one road, then your developers don't need to be involved at all. The sort of web server is just going to speak a different language to the browser, and so there it's really just a case of making the necessary changes to your web server. So if you're on Nginx, sort of installing the necessary plugins and upgrading to the version if you're on an older setup. Or, as I said, like the easiest way, even if you don't already have a CDN, you can get accounts on Cloudflare for $10 a month with unlimited bandwidth. there's very little reason like even small businesses can't do that. And so in that case, you really don't need any developer resource at all, but you do need the sort of server guys to make the change.
Right. Okay. I mean, it just ties in nicely into a couple of questions. One particularly from Jeff Rinkley. Does HTTP2 require the use of CDNs, and how do CDNs handle when I make changes to my site? Does it need to propagate?
You don't need a CDN for HTTP2. You can have the HTTP2 without a CDN. You can have a CDN without HTTP2. The nice thing about CDNs, as I've mentioned, they're a really easy way for you to deploy the change. But secondly, you can get there's still a benefit to having a CDN, even if you've got HTTP2, because in the example I showed where you might be in London requesting a website from San Diego, even though you can have multiple trucks on the same road and the sort of the queuing problem goes away, they still need to drive all the way to San Diego and back. So you're still sort of increasing the latency. Whereas if you can cache them closer to your user, and that's what CDNs do, then there's still a huge benefit. And so, yes, like CDNs are a great way to do it, but you don't need them. Most of the CDNs, it's just literally a turn it on, like go in, press the I want HTTP2 button, and it'll start doing it for you. So super simple.
Cool. Fantastic. And then there's a question here from a couple of people who are asking around, obviously, the world of mobile and everything like that. So JJ NATO mentioned in one of his questions. He just basically said, is there any difference between, when you're implementing HTTP2, is there any difference between desktop and mobile sites that you need to consider in the process?
Nope, it's the same thing again. Like there's little downside to HTTP2. Most of all the sort of modern smartphone browsers speak HTTP2, and so you'll get the speed benefits there, and where it most matters, because sort of certainly if people are on the move, the latency problem is sort of a bigger problem for mobile users. But because you're not changing anything about the HTML or the actual like content of those pages, there's no sort of consideration for, oh, this is going to a mobile that you need to worry about. It's all just about how the data gets to the browser, whether that's a smartphone or a desktop. Once the data's there, the browser doesn't actually really care if it came over an HTTP2 connection or an HTTP1 connection. It's got the same HTML, and it doesn't even need to know how it got there, essentially. So in terms of desktop versus mobile, there's really nothing you need to consider, I don't think.
Okay, good to know. Gary as well has picked up on obviously the Cloudflare side of things. If I use Cloudflare to authenticate HTTP2, would activating it on my server help improve latency even more? Interesting.
So yeah, well, I think that's similar to the answer I gave a couple of questions ago, where you can have the other benefits of CDN on top of HTTP2, and so previously, without the HTTP2, some websites, there wasn't necessarily a reason that they should get a CDN. If all of their users are in a tight geographical area and their servers are in that area, then there's not a huge benefit. But if you are dealing to international audiences or audiences across multiple sort of regions, countries, then there are edge cases, but almost always sort of deploying a CDN properly is going to be a sort of performance increase, and it's going to lighten the load on your servers, because the CDNs are going to start serving images for you and reduce like the bandwidth bill that you're going to pay on your server, all of that stuff. And so, yeah, very few reasons not to do it. And to respond to the question, yeah, you'd get the double improvement in latency, moving the stuff closer to the users and delivering it over HTTP2.
Fantastic. Quick, easy one for you, mate. Shanti just calling out something that you mentioned in the presentation. What was the tool for checking the protocols via the browser again? You had shown it in the URL, so can you just clarify what that tool was?
So I think you can all still see my screen. So if you open the Chrome developer tools in Chrome, this is the first one I showed. And basically, in the Chrome developer tools, you normally get a sort of default set of columns that it shows you. but you can actually turn on other columns. And one of the columns you can turn on is called the protocol column, and it'll just show you there. So inside the Chrome Developer Tools, inside the network tab, it will just show you, okay, this was sent over HTTP1, this was sent over HTTP2, this was sent over Speedy, whatever. I find it really useful for quickly sort of seeing. Remember, and as per the sort of screenshot I've got on the slide, that one website could actually be delivered from multiple servers. So sometimes you might be referencing an image that's on another server, and you might be using like a jQuery library or something that's on another server. So you might end up with your browser connecting to multiple different servers. Those servers could be speaking different protocols. So you might end up in a scenario where some of the requests are coming over HTTP2, some of them are coming over HTTP1. That's perfectly normal, nothing to worry about. And so that was the first one I showed. The second one was a Chrome extension, which you can download if you just go to dis.tl/show HTTP2 and install that Chrome extension, and then it just puts a little lightning mark into your sort of Chrome next to the address bar, and the lightning displays different colors to indicate to you which version of HTTP2 a website is using, and you can hover over it and it'll tell you more information. So that's really easy if you just sort of want a quick way as you're browsing around to see, oh, that's using HTTP2, or that's still on HTTP1. But the protocol tab is the sort of power user way of doing it.
Fantastic. Well, I'm just getting so many questions now, Tom, to be honest with you. We're just inundated. So I just don't think we can get through them all, really, in some respects, in some ways, in the next sort of couple of minutes. So I'm actually kind of gonna.
So my Twitter's on the screen now. It's @TomAnthony SEO. And so if anybody has any follow-up questions, then tweet them over to me, and we can take the discussion to Twitter.
Brilliant. I mean, we're not going to let you get off that light, mate, in all honesty. What we'll do, what I was going to say is, I mean, it's just, we're running out of time. And I mean, I really thank everybody for listening in. And obviously, I thank you yourself, Tom, for coming on and doing this. It's just suddenly started to generate a snowball of questions around so many different things. What we'll probably have to do is, like we've done on previous webinars, because we'd like to try and get back to everybody, because we appreciate the time for you guys to take the questions, is to probably put a blog post together separately on the questions and get the questions over to Tom, let Tom put a one-liner against each one and fire it all back to you guys. You know, the engagement here has been fantastic, so I thank everybody that's kind of come on and done that. If you have a look in the chat box link currently within the webinar section, there is our site speed white paper, and there's been a few questions asked around site speed, so we put that back in there for you guys now. So if anybody wants to download the white paper around site speed, please do grab that. The recording, as I mentioned, will be emailed out tomorrow to everybody that registered. We'll push the slides out, and there'll be a blog post wrap up tomorrow afternoon around the webinar, as just takes you through step by step of everything that Tom's talked about today. And obviously, as I mentioned, we'll look to do an extra one and answer some of these questions. Our next webinar is on the 30th of August with Mr. John Doherty, who's the CEO of Credo, on the benefits of SEO monitoring, which I think will be really interesting to get into as everybody's back from the summer holidays and starts to roll into September. And we do love feedback, as I did mention. So please do take the time to fill in our survey. And really just to give you a heads up as well on something completely left field, because it's something we've been talking about for a little while at DeepCrawl. We've literally today just launched JavaScript crawling, which will tie into some of this stuff around some of the questions that have been asked here as well. So if you are interested, take the time to check out on the DC blog. We just put a post up on our JavaScript capabilities from a DeepCrawl perspective. Or if you are interested in finding out more about it, just email us at hello@deepcrawl.com. It's hello@deepcrawl.com, and we can pick up any questions. But that's just another thing that's literally gone live as we've been on this webinar. So I just wanted to keep you guys up to date and give you a little bit of first mover advantage for attending the webinar. So again, a big thank you for listening in. Massive thank you to Tom Anthony. Thanks, mate, for taking the time to come and do this with us.
Thank you very much. It was fun.
And my name is John Wise, and it's been a pleasure to do a very, very interesting, very informative DeepCrawl webinar again. And we will continue to do these, as I mentioned, the next one on the 30th of August. Thank you for your time, everybody, and thank you for listening in again. Thank you.